Hello everybody, this is Mr. McNair, and this is 3.5 lesson on scatter plots and trend lines. What we're going to do is we're going to go ahead and allow you guys to take notes. Just kind of the substitute will pause the video when you guys need to write some things down. So go ahead and take a moment, copy down the title and the dates. You do not need to draw the coordinate grid on this one. Alright, so real quick, let's just kind of review some terms here. So when we were talking about our coordinate plane, this whole thing is called the coordinate plane. Okay. Now the coordinate plane is divided using the y-axis, which is our vertical axis, and our x-axis, which is our horizontal axis. Alright, the intersection of our x-axis and y-axis is this point here, and we call that what? The origin. The x-axis and y-axis divide our coordinate plane into 4 quadrants. So we have quadrant 1 here, quadrant 2 here, quadrant 3 here, and quadrant 4 here. Okay, so those are just some terms that you need to make sure you keep in your mind. Also, once again, you don't need to write this one down. However, just to review, if we were to take the point A 2.1 and plot that, that would be the point here, 2 on the x, 1 on the y, so that would be at that point there. Then the point B, 5, -3, so we go over to 5 on the x, down to -3 on the y, so that would be the point here, B. C at the point -3 for the x, 0 for the y, so there's C. D, -2, -2 is there. E, 0, 4. That's here. This is E. And then F, -2 for the x, +3 for the y. Okay, so just take a moment and make sure that you understand how we place points on a coordinate grid. Now, other questions that you might get would be, once again, tell what quadrant or axis the point lies in or on. So if we were to look at point A, that would be where? Quadrant 1. Point B, quadrant 4. Point C. Now be careful with that one. This one is the x-axis. Remember, if it's on an axis, it's not in a quadrant, it's on an axis. Point D, that's quadrant 3. E, the y-axis, very good. And F, -2, 3 is in quadrant 2. Alright, excellent. Let's move on. Now, could you please write down what is underlined in blue? Alright, so if you need to pause the video here, that's fine. I'm going to go ahead and read the whole paragraph. Many real-life situations can be described in terms of pairs of numbers. Medical charts record both the height and weight of the patient, while weather reports may include both temperature and wind speed. Now, the part you're writing down, once again, is a scatter plot is a graph with points plotted to show a possible relationship between two sets of data. So here's an example of a scatter plot. You even had an example of the scatter plot at the beginning of the lesson when it came to the lemonade and the temperatures and so on and so forth. Now, this scatter plot shows us about winter equipment. Winter equipment. It talks about in the x-axis the years since 1990. And the y-axis, we're talking about the amount spent in millions of dollars. Okay? So, what do you notice about the snowmobiles? What do you notice about that graph? Well, looking at that, we could say that the blue dots, the snowmobiles, that the amount spent on snowmobiles was in general increasing from one year to the next. All right, what do you notice about the ski equipment? That one remains relatively constant. Okay. Now, when we're looking at graphs such as these scatter plots, we don't really look at every individual specific point. We look at the general trend that is followed by the graph. Okay. So even though there might be some examples in here where we go down, then up, then down, then up, and so on and so forth, the general trend for ski equipment is that they actually remain relatively the same. Relatively constant. All right, you do not need to write this one down. Okay, you do not need to write this one down. This says make a scatter plot of the data. Use height on the horizontal axis and weight on the vertical axis. All right, so this is talking about the weight of soccer players on a specific team. We measured our height in inches and our weight in pounds. So just so that we know this, how many inches are in a foot? 12 inches. So how tall in feet is a person that's 72 inches? Yeah, that person would be 6 feet tall because 12 goes into 72 6 times evenly. How tall would a person that's 70 inches tall be in feet? That would be 5 foot 10 inches. Okay, and then let's do one more of those. This person over here, this 76-inch tall person, how tall would they be? That person would be 6 foot 4 inches. Okay, good. So here, let's plot our points. So notice we have labels for our x and y axis. The person that is 72 inches tall, they weigh 190 pounds, so we'll put them here. The person 70 inches tall is 170, so we'll put them here. Person 71 inches tall, 180. 70 inches tall again, we have a person at 175, so that's about there. 69 inches tall is at 160, so we'll put them about here. 70 inches tall again, we got another person at 160. We got a 69-inch tall person that weighs 150 pounds, so that'll be there. 73-inch tall person that weighs 180 pounds, so 73 inches, 180 is here. 66-inch tall person, somebody a little bit short on the team, 150. 70-inch tall person at 150. And then we have our team giant, 76 inches tall at 200 pounds. Okay. So now, just looking at that graph, what in general can we say about the graph as far as how does the weight change as the height changes? In general, we could say that as height changes, as height increases, the weight also increases. And we know that's generally true. Now, is that true for every single case? No, it's not. You have some people that are taller that still weigh less than people that are shorter than them. However, in general, as a person's height increases, in general, their weight tends to also increase. All right. Now, this one, I do want you to write this one down. Just write down, just write down this table. You don't need to write down the words above it. Okay, so what I want you to do is take the table here, and I want you to graph it using a scatter plot. All right, so go ahead and pause the video. Go ahead and give them some time to go ahead and graph this data. All right. All right, after you've graphed it, you should notice that one day after the cookies were baked, there were 24 cookies in the jar, so that's here. 2 days after, we were at 16 cookies, so that's about here. 3 days after, we were at 10 cookies, so that's about here. 4 days after, we were at 7 cookies, so that's about here. All right. And that's our scatter plot. So, once again, what general trend can we say about our graph? Well, in general, as the time increases, the number of cookies in the jar decreases. All right, great. Let's move on. Now, let's talk about correlations. You do need to write down. Everything that's on this slide. All right, now there's 3 types of correlations we're going to talk about. The first type of correlation would be things that are positively correlated. Meaning as one increases, the other increases. Both sets of data values will increase at the same rate. For example, as you're writing this down, when we were talking about the lemonade, as the temperature increased, the number of lemonades sold also increased. So those are positively correlated. Okay, as one increases, the other increases. Another example of something like is positively correlated would be the height and weight of the soccer players. As the height of the soccer player increased, so also did the weight. All right. Next, we have negative correlation. As one set of data values increases, the other set decreases. So, for example, that's why I put the cookies up here. All right, the cookie example that we just had in the last slide, that was something that was negatively correlated because as the time increased, the number of cookies in the jar decreased. So as one increases, the other one decreases. All right. Another example from the opener, when we were talking about how the temperature increases and the number of hot cocos would also decrease because as the temperature increases, the number of people that buy hot cocoa would drop. And then the last type of correlation we have is no correlation. That's just saying these two sets of data are not related in any way whatsoever. Okay? Yeah, so that would be it. And we'll talk about a few examples of that. All right, you don't need to write this one down, but this one says, describe the correlation illustrated by the scatter plot. You have TV watching and test scores, right? So, what do you notice as the amount of TV watching increases? The test scores do what? Decrease. So what type of correlation would this be? This will be a negative correlation because as TV watching increases, the test scores decrease. Okay? Once again, you don't have to write this one down. Here we're talking about beach visitors. Whoops. Let me go back. Beach visitors. What do we notice about the temperature? As the temperature increases, what do we know about the number of people that visit the beach? That also increases. So as one increases, the other one increases, then we know that this is a positive correlation. All right, let me just break down this word correlation real quick. Correlation is made up of two Latin bases. Co, which means together with, and relation is talking about how things are related, how their relationship is. So we're talking about how are these two values related. In this one, they're positively correlated because as one increases, the other one also increases. All right, do me a favor, and I want you to write down this part here. I want you to take a little bit of time after you write it down. We could pause the video, and I want you to tell me how these sets of data are correlated. All right, it's a positive correlation, negative correlation, or relatively no correlation. All right. So after you've paused the video, here, let's talk about it. The number of empty seats in a classroom and the number of students seated in a classroom. This one would be a negative correlation. And the reason why it's a negative correlation is because as the number of students increases in the classroom, what happens to the number of empty seats? They decrease. So one increases and the other one decreases. So that's negatively correlated. All right, go ahead, pause the video, and write down this part here. And go ahead and discuss, what you think the answer would be. All right, so the number of pets a person owns and the number of books a person read last year. How are those two values related? Well, honestly, they're not related at all. There's relatively no correlation here. There's people that own a lot of pets and read no books. There's people that own no pets and still read no books. So there is relatively no correlation between these sets of data. All right, moving on. All right, go ahead. Write this down. Pause the video. Talk about what you think the answer is. All right. The number of people in an audience in ticket sales. This one is positively correlated. Once again, we're looking and saying the number of people, as the number of people in an auditorium or in an audience increases, the number of ticket sales also should increase. All right, so therefore this is positively correlated. Just so that you guys know, this is the beautiful Twinsburg High School auditorium. Isn't it nice? All right, let's move on. So, part D, go ahead and take a minute, write this one down. Discuss your answer. Okay, so the time since the start of a race and a runner's distance to the finish line. This here is a negative correlation. And the reason why this is negative is because as the race continues, as the race time increases, the runner's distance from the finish line should decrease. The longer the person runs, the closer they get to the finish line. So as the race increases, the distance to the finish line should decrease. So as one increases, the other decreases. That's negative correlation. All right. So if the person was running longer and their distance to the finish line was getting farther away, well, they would be running in the wrong direction. So here we're talking about a negative correlation. All right, almost done. You don't have to write this one down. This one says, choose the scatter plot that best represents the relationship between the number of days since a sunflower seed was planted and the height of the plant. Explain. All right, go ahead and pause the video and allow everybody to discuss this for a moment. All right, answer is C. We're talking about a sunflower seed. You're not going to start a seed and it be 70 inches tall. Not so. Also, you're not going to start a seed and no matter what, you can't have negative inches tall. That's just not possible. Okay? Even if the seed goes into the ground, it's still not negative inches tall. You don't have a negative 20-inch tall plant. It doesn't happen. All right. Next one. Choose a scatter plot that best represents the relationship between the number of minutes since a pie has been taken out of the oven and the temperature of the oven. Explain. So go ahead and take a moment. Pause the video. Discuss your answer. All right. Here, the answer is graph A. Okay. When you take the pie out the oven, then you turn the oven off, and then the temperature in the oven should be decreasing. Okay, so that's what we're doing there. Part B doesn't really make sense because, number one, you can't have negative time. But even still, this is kind of like saying, if I've had people say, well, Mr. McNair, this is a time before they took the pie out the oven. Well, okay, if that's the case, why would you start turning off the oven before you took the pie out? Okay, that doesn't really make sense. So that's not that one. And then here, hopefully after you take the pie off the oven, you don't start the oven up. All right, that doesn't make sense either. So that's not the answer. All right, there it is. So this is your homework. You can go ahead and pause the video here and allow students to go ahead and write down the assignment. All right. This assignment is due next class, which is on Monday. All right, ladies and gentlemen, have a great weekend, and I will see you next class.